Good day, everyone. I am Carmel Joy Ockman, a basic science student. Together with Riolo Mauricio and Sharon Agyang, we are going to discuss to you about the stars, galaxies, and the universe. Milky Way galaxy, type of galaxies. So before we start, I'm going to present to you the learning objectives of my assigned topic, which is the stars. So at the end of the discussion, the students will be able to define stars, describe the flow of energy in a star, classify stars based on their properties, outline the life cycle of a star. So star is a huge sphere of very hot glowing gas. So stars differ in size, temperature, and age. Many stars produce more energy than the sun, and the energy source for all stars is nuclear fission. So we all know that stars are made mostly of hydrogen and helium, which are packed so densely in a star that in the star's center, the pressure is great enough to initiate nuclear fusion reactions. So in a nuclear fusion reaction, the nuclei of two atoms combine to create a new atom. Most commonly in a core of star, two hydrogen atoms fuse to become a helium atom. Although nuclear fusion reactions require a lot of energy to get started, but once they are going, they produce enormous amount of energy. So in a star, the energy from fusion reactions in the core pushes outward to balance the inward pull of gravity. This energy moves outward through the layer of the star until it finally reaches the star's outer surface. So the outer layer of the star glows brightly, sending the energy out into space as electromagnetic radiation, including visible light, heat, ultraviolet light, and radio waves. So how stars are classified? So astronomers classify stars according to their physical characteristics. So characteristics used to classify stars include color, temperature, size, composition, and brightness. So stars vary in their chemical composition. Star's color is also determined by the temperature of the star surface. Relatively cool stars are red, warmer stars are orange or yellow, and extremely hot stars are blue or blue-white. So, the brightness of a star also depends upon both its size and its temperature. How bright a star looks from Earth depends on both its distance from Earth and how bright the star actually is. Classifying stars by color. So, color is the most common way to classify a star. So, as you can see in the table, the class of a star is given by a letter. Each letters correspond to a color and also to a range of temperatures. So, the class O star, the color is blue. The temperature range is 30,000 kelvins or more. The sample star is Zeta Ophiuchi. The class B star, its color is blue-white. The temperature range is 10,000 to 30,000 kelvins. So the sample star is Rigel. The class A star is white. The temperature range is 7,500 to 10,000 kelvins. The sample star is out there. The class F star, its color is yellowish white. The temperature range is 6,000 to 7,500 kelvins. The sample star is Procyon A. The class G star, its color is yellow. The temperature range is 5,500 to 6,000 Kelvin. So the sample star is the Sun. The class K star, the color is orange. The temperature range is 3,500 to 5,000 kelvins. The sample star is Epsilon Nd. The class M star, which is color red, temperature range is 2,000 to 3,500 Kelvin. So the sample star is Betelgeuse Proxima Centauri. So for most stars, surface temperature is also related to size. Bigger stars produce more energy, so their surfaces are hotter. These stars tend toward bluish white. Smaller stars produce less energy. Their surfaces are less hot, and so they tend to be yellowish. Lifetime of stars. So stars have a life cycle that is expressed similarly the life cycle of a living creature. They are born, grow, and change over time and eventually die. Most stars change in size, color, and class at least once in their lifetime. What astronomers know about the life cycle of stars is because of data gathered from visual, radio, and X-ray telescopes. Life cycle of a star. So, just like people, stars have different stages depending on their age and size and grow to become even larger until they finally lose their life. There are two different paths of which a star can be created. So the first path occurs when a region of high density in a stellar nebula condenses into a single point of matter that becomes hotter and starts to glow. Particles of dust and gas are the first ingredients used to make stars. Baby stars are commonly known as protostars. So, the star then heats up and shines brighter. It is now an average star. It becomes a red giant when its outer layer cools, expand, and glow red. The outer layers finally drift apart, creating a planetary nebula and a white dwarf star. In its final stages, the white dwarf dies out, becoming a black dwarf. Path 2. Just like average stars, massive stars are formed from gas and dust in a nebula. Massive stars, however, are much larger and transform into supergiants. Eventually, the star's core will collapse, causing a supernova explosion. After the explosion has taken place, the supergiant's core can turn into a neutron star or a black hole. I guess that's all for today's learning and my report. Thank you for listening.